Hey everybody, hope everyone's well. Welcome to the last video of the spring 2020 COVID-19 school dismissal. Congratulations, we're almost there. Thank you so much for all your hard work. These last few weeks we've been talking about climate change and how light in the atmosphere interacts with molecules to create this thing called the greenhouse effect, and we've talked about some evidence of climate change, some of the impacts. But we have not yet talked about the cause of climate change, and so that's what we're going to get into in this video, and this will lead to a project that you will have to do as a final project for next week. So without further ado, we're going to be talking about energy and society, some learning objectives for you. I can describe different renewable and non-renewable energy sources. I can evaluate the positive and negative economic and environmental impacts of different energy sources. And I can argue what I believe the future of energy should look like on planet Earth. All right, so I'm going to just jump into what is energy. Energy is the ability of an object to cause change. Nothing changes in this universe without energy as kind of the driver behind that. There are many types of energy, and you can see them here over on this list. You've probably studied a lot of these in middle school. There's kinetic energy, electrical energy, thermal energy, radiant energy, sound energy, chemical energy, nuclear energy, gravitational energy, elastic energy, so on and so forth. And through an event, energy transfers from object to object or type to type. But the total energy of an event is always the same, and that's why we call it that's what we call the law of conservation of energy. All the energy in the universe is constant. It's just moving around. And then the last important piece to know about energy as it kind of applies to society is as energy flows, it becomes less useful. It's often lost as heat with the surroundings over time. Another way of thinking of that is it becomes less concentrated. Energy has a tendency to want to spread out. And the efficiency of a system is a percentage of energy you get out for how much energy you put in. So here's a little graphic to illustrate some of what we just talked about. First of all, if we have 100 units of energy show up at a power plant in the form of coal, that would be a chemical energy. We can burn that coal, convert it into thermal energy to create electrical energy. In that process, 62% of that original 100 units of energy is already lost as heat. We already lost 62% of it just in the production of electricity. And then it goes into your transmission lines. An important thing to note that we'll talk about is electricity is not a source of energy, it's a means for transporting energy. And in the power lines, we put in 38 units of energy. 2 are lost in the power lines as heat. And then that arrives at your house, and you have 36 units of energy that you can put into a light bulb. If it's an incandescent light bulb, that's the old school style, then 34 units of those units of energy are lost as heat, which is not the purpose of a light bulb. And only 2 units of energy is going towards producing light, which is the purpose of a light bulb. So in this process here, you can see that 100 units of energy at the power plant gets us only 2 units of energy at the light bulb. So I would say that overall this is 2% efficient. So why is energy important, you might wonder? Energy is what powers society. Since humans are constantly needing to cause change, right? Energy causes change for things like transportation, heating, lighting, manufacturing, etc. We have a need or a demand for energy. Our energy demand has increased as our technology has become more advanced. That should make sense as we have created things that use energy, therefore we need more energy to power them. To meet this energy demand, we extract energy from nature, and we call these places where we get energy primary energy sources. And my webcam is blocking it a little bit, but here are renewable and non-renewable energy sources. And for your final project, you'll choose one of these and research it. I'll give you an example of that in just a little bit. And then the last thing I want to note is, as I was saying on that last slide, electricity is not a primary energy source. There is no place in nature where we can just plug in and get electricity. Electricity is a convenient way to transport energy from some other source. And so a power plant like that coal power plant is taking the natural coal and converting it into electricity so that we can conveniently send that energy out throughout society. But that's an important thing to note, especially one example I like to give is like, if you have a Tesla, an electric powered car, you should know still where you buy your electricity, because your electric powered car is actually powered by whatever is producing your electricity. So if you have solar panels on your house, it's a solar panel powered car. But if you have a coal plant that produces your electricity, then it's actually a coal powered car. And this little graphic shows how our energy demands have changed over time. First of all, just in general, they've increased, but also we've started to get our energy from different energy sources. So back in the early 1800s, wood was the top winner. The late 1800s into the early 1900s, it was coal, and then petroleum is definitely the big winner these days. Natural gas is also up there, nuclear, and then other renewable energy sources, which this is for 2012. I'm sure those have increased since. So what's the big deal with energy? Especially in the context of climate change. When humans extract energy from nature, there's always pros and cons. Different sources of energy can have different positive and negative economic impacts, which includes anything relating to money, jobs, business, government, or society. So when you think of economic impacts, think about how it affects people. And then different sources of energy can also have different positive and negative environmental impacts, which includes anything relating to natural ecosystems, plants, animals, air, water and soil quality, or the climate. So environmental impacts are anything relating to nature. Where we get our energy is a major topic of the 21st century. Pretty much any modern presidential candidate is expected to have this as part of their platform of what does that candidate see as the future of energy in America? And so for your final project, you'll research and present information on an energy source of your choosing. What is it and where does it come from? How do we get it and turn it into electricity? And what are the positive and negative impacts of us extracting it? I'm going to do a quick example of that. I'm going to cover the big one, petroleum, and I'll run through this fairly quickly. I can certainly be long-winded when talking about petroleum. There's a lot to say, but hopefully this is an example of what am I looking for when you go to do this final project. So without further ado, my thesis of this particular presentation would be petroleum is the most important material of the 20th century. We're not far enough into the 21st century yet for me to make that statement, but certainly in the 20th century, the 1900s, petroleum was revolutionary, changed the world. By the way, on the assignment, these slides, this example presentation, is for the PD expectations only. If you just want to get the P expectations, you do not need to watch this part of this video, but I'd highly recommend everyone be literate, be aware when it comes to petroleum because of its importance to society. So, what is petroleum? It's also known as crude oil. It's a set of molecules rich in chemical energy. It looks like a black viscous fluid, and it is a non-renewable resource, which means we can't make more petroleum. Quick history of petroleum dates back to ancient Persia and China, where chemists would extract this liquid from the ground and noticed it could be burnt. That process was kind of revised in the Middle Ages in Arabia when chemists started to realize that there are multiple chemicals in there that could be separated, which is kind of a precursor to distillation. In the 1800s, and accelerated by colonialization, we started to look all over the world for petroleum started to recognize, as the Industrial Revolution set in, the power of petroleum. And so um, we were hunting the globe for petroleum. By the 20th century, petroleum greatly impacted the world wars, World War I and World War II. It was it was allowing us to create machines for war instead of just soldiers. And so we see that with airplanes, tanks, all of those modern military inventions could not be powered without petroleum, battleships. Here's an interesting propaganda poster from America in the 1940s during World War II. When you ride alone, you ride with Hitler, trying to get Americans to conserve petroleum. And then certainly modern conflicts are influenced by petroleum, where petroleum resources are on the globe. We saw that with the first Gulf War, the second Iraq War, and even today, things like the civil war in Syria have all occurred on this backdrop of petroleum. So how does petroleum form naturally? It's a process that happens over hundreds of millions of years. It starts in a marine environment where huge algae blooms and zooplankton, so those are little plants and animals that are floating in that ocean or lake. They grow, they harness the radiant energy from the sun, and through photosynthesis capture it as chemical energy, and then they die and they sink to the bottom, and sediment layers on top of them. And then over hundreds of millions of years, the heat and pressure of that overlying sediment starts to squeeze the energy-rich molecules out of those microscopic plants and animals and concentrate it in oil. Kind of like how you'd squeeze olive oil out of olives. Here it's hundreds of millions of years squeezing petroleum out of decaying or dead plants and animals. And that is why we call it a fossil fuel. Here are some of the major oil and gas reserves in the world, just a good map to be aware of, because you hear about a lot of these things in the media, certainly the Middle East, the North Sea, the Gulf of Mexico, in Alaska. Those are all Venezuela. Those are all associated with petroleum related media articles. How do we detect petroleum? This is a interesting process where we drive over land or sail over water. We send out seismic waves and basically listen for their reflection. And when their reflection changes, we believe we have a petroleum deposit. So petroleum companies don't just start drilling haphazardly in the ground. They have a lot of technology to try to find where petroleum is before actually drilling. And then how do we extract petroleum on land? We use things called oil wells or derricks. Essentially all you do is you drill down and put a big pipe in, kind of like a straw, and then use some pumps to suck it up because it's a fluid. And then how do we extract petroleum offshore? Very similar process, but much larger infrastructure. We build what are called oil platforms or oil rigs that are kind of like floating cities. They're huge. Some can be anchored into the seafloor, but tend to be floating. And again, a big straw goes down and sucks up the petroleum out of that deposit. Here's one unique and controversial way of petroleum extraction called hydraulic fracturing or fracking. High pressure water is injected into the rock. So they drill the hole, they place their straw, the pipe, and then instead of sucking the petroleum up, they send down high pressure water, sometimes with other chemicals, like sand as an abrasive or acid as a chemical agent. And the point of that is to fracture the rock under the earth. And when you fracture the rock, it releases tightly bound oil and natural gas deposits. And then from there, you can suck it up. How do we refine petroleum? So once we've got the crude oil out of the ground, it goes to oil refineries. And they use a process called fractional distillation. I'm going to turn my screen off real quick. Fractional distillation basically uses heat to heat up the crude oil and then separate the different compounds based on their size. The lightest compounds, chemicals with 1 to 4 carbons, float to the top. The heaviest compounds, compounds with over 70 carbons per molecule, sink to the bottom. And along the way, you get everything in between. And this allows us to create a huge, or to refine a huge amount of chemicals out of that crude oil, which is, again, a set of chemicals. So some things we can refine out of petroleum include gasoline, liquefied petroleum gas. That would be like propane for your grill, diesel fuel, jet fuel, heating fuel, and then a lot of chemicals, which many people don't think about. Petroleum is also our feedstock for producing things like plastics, oils, waxes, polishes, makeup, and we'll talk about that a little more in a future slide. How do we transport petroleum? We have lots of different infrastructure for transporting petroleum. You've seen petroleum transported around your community in semi-trucks. On a larger scale, petroleum can be transported with pipelines or tankers. How can we produce electricity from petroleum? Some of you might have a generator right here in your house. Other ways to produce electricity from petroleum is essentially the same method, but on a larger scale in a power plant. What happens is you take the chemical energy from the oil, you burn it to produce thermal energy in the form of steam, and then that steam, which tries to escape, much like the steam in a teapot on your stove, that steam is going to push on the blades of a turbine and cause a shaft to start to spin. And that shaft is connected to an electrical generator, which is essentially just magnets wrapped around coils of wire. And as those magnets spin, an electric current is produced, and we send that up into our power lines. And with that said, only about 3% of the electricity in America is produced with petroleum. So that's a pretty low number. Although, again, like I said, some of you might have a gasoline generator as a backup. That would be an example of residential electrical production. So why don't we produce more electricity with petroleum? The main reason is it's so valuable that we use it for other things that can't be powered by different energy sources. The big one is transportation. Over 89% of the energy in transportation comes from petroleum. So you can see that here. Gasoline is a big one, what we put in our cars. Distillates like diesel fuel or shipping fuel, and then jet fuel all come from petroleum. So a huge part of this slice of the pie. And then internal combustion vehicles, again, like your cars, planes, trains, boats, they all run largely on petroleum. Another big use of petroleum is heating oil, is for heating. So you can make heating oil, kerosene, to heat up either water in a boiler or air in a furnace and force that hot water or air throughout your house, and it keeps you warm at night. So if you have something like this at your house, that probably houses heating oil, and then something like this in your basement is a furnace where it's burned to keep your house warm. Something I learned in doing this presentation is that using petroleum as heating oil is by far a New England thing. I never knew that. And then lastly, you can use petroleum to cook with. So some of you might have a propane stove or grill at your house that's using petroleum to cook. Other uses of petroleum include chemicals, like I said earlier. All plastics are made out of petroleum, which I think not many people think about, but every single piece of plastic used to be crude oil, which is an interesting reason against why we should have single-use plastic, because every time you throw away a piece of plastic, it's like throwing away oil. A lot of solvents, things that dissolve things, are made from petroleum. A lot of cleaning supplies, cosmetics like lipstick or mascara that you rub on your face are made from petroleum, and even pharmaceuticals, drugs like ibuprofen, for example, could be made from chemicals that were distilled out of petroleum. So here are some positive economic impacts of petroleum. And again, when I say economic, I'm referring to people, things that affect the economy or are related to money, jobs, government, society. First, it's relatively cheap and easily extracted. It provides energy to improve the quality of life in developed nations. It's pretty well defined that there's a correlation between your quality of life and how much oil your country consumes. The more oil your country uses, the better life you're going to have, for better or worse. It's easily transportable, as we talked about. Got a high energy density, which means that in a small amount of volume or weight, it can hold a lot of energy. That's what makes it so good for powering our cars. We couldn't have a wood powered car because it's got a very low, wood has a very low energy density. It creates jobs in exploration, extraction, refinement, transportation. There's a huge petroleum sector out there that's creating lots of jobs for our country. Got broad applications like we saw: transportation, electrical production, heating, cooking, making chemicals. It can provide a constant source of electricity. So some who say solar panels don't work when the sun's not shining, or wind turbines don't work when the wind's not blowing. Well, we can always burn petroleum. So it is consistent in that sense. And then lastly, we have a very established infrastructure and technology in our country around petroleum. What I mean by that is we have, I think, like 7 gas stations just in Morrisville. So if we were to try to make a switch away from petroleum, it would cost a lot of money to replace all that infrastructure. If we all went to electric cars, you have 7 gas stations that would then need to be replaced as electric charging stations. Negative impacts, economic impacts of petroleum include it's non-renewable, which means eventually, if we keep consuming it, we will run out. It takes hundreds of millions of years to make petroleum, so it's not anything we can make artificially on our time scale. It's dangerous to extract. People definitely have died in the extraction of petroleum. It contains toxic compounds that affect human health. Gasoline alone has a compound called benzene, which is a carcinogen, and so that is costly and concerning when a compound so widespread through our society is affecting public health. It can create a dependency, either individually or nationally. What I mean by that is I think we as a country and us as individuals are addicted to oil. We could not live the lives we live without oil. I couldn't commute from my home in Richmond 45 minutes to Morrisville every day without having petroleum powering my car. And then lastly, it can sustain terrorism and other humanitarian crises. And what I mean by that is it can provide money to governments that are not democratic and not taking care of their citizens, like we saw with Saddam Hussein in the Iraq War. Some negative environmental impacts of petroleum include, and I will say before I go through this list, that there are no positive environmental impacts of petroleum. There's no reason burning petroleum is good for our natural world, which is why I don't have a slide for that. The big one is that carbon dioxide from the burning of fossil fuels is a greenhouse gas. So when we burn petroleum, we produce carbon dioxide, and as we've studied, that is a greenhouse gas which increases the greenhouse effect and the global temperature on planet Earth. Other negative environmental impacts are oil spills, which we'll talk about in a second, but those are devastating to the ecosystem wherever oil is spilt. It gives off other types of air pollutants beyond greenhouse gases, ones that can just cause respiratory irritation or cancer or other health problems. And if it affects humans, then it will affect other animals as well. It can cause acid rain from those air pollutants. When they mix with water vapor in the sky, they can create an acidic solution, which when it rains can totally decimate ecosystems, especially trees who cannot move out of the way. It leads to water pollution, either through spills or just minor leaks, like at a gas pump or from a car, where you have oil leaking out of some container and that's getting into the waterways. And then ultimately, it's just toxic to organisms. So when petroleum gets into our ecosystems, things tend to start to die. I'm going to go over just a couple of those major environmental impacts. One was oil spills. Two of the more notable oil spills in human history are the Exxon Valdez, which was an oil tanker that crashed, I believe, off the coast of Alaska and spilled a large amount of oil. And then an even bigger one was the Deepwater Horizon event back in, I believe, 2010 in the Gulf of Mexico, where an offshore oil rig actually had its underwater cap well explode, and that led to the death of people on the oil rig as well as a major environmental crisis in the Gulf of Mexico that region is still recovering from. And then next, the other big negative environmental impact of burning petroleum is global climate change. Carbon dioxide released through petroleum combustion is a greenhouse gas. And as we do this all over the planet in very large amounts, every time you drive your car or heat your house or produce some electricity with petroleum, we are increasing the greenhouse effect on planet Earth. And that increase in the greenhouse effect is leading to an increase in temperature and moisture in the atmosphere. And that's what segues us back to all of those different sources, or excuse me, implications of climate change. And we've got just one video here. We're just going to watch this real quick. I hope it was capturing the sound from the computer. But anyways, guys, if you just made it all the way through my spiel on petroleum as an example of an energy source and an analysis of an energy source, congratulations. Thank you so much for putting up with me throughout this whole dismissal. Again, as your final assignment, your task will be to choose an energy source and list some of its, describe it. How is it formed naturally? How do we extract it? How do we use it to produce electricity? And then list some of its positive and negative environmental and economic impacts. Please stay in touch. Let me know if you have any questions, and keep on keeping on. See you when I see you.